Welcome to the first lesson of the AI Large Model Popular Science course for everyone. What is AIGC? Let's clarify a bunch of AI-related tech terms. When it comes to recent hot tech buzzwords, AIGC undoubtedly ranks among them. But do you really understand AIGC? Starting one day, we suddenly discovered that AI can help generate text, images, audio, video, and more. So well that it's often hard to tell whether the creator behind the content is human or AI. This AI-generated content is called AIGC, short for CV-generated content. Examples like articles generated by ChatGPT, code generated by GitHub Copilot, and images generated by Midjourney all fall under AIGC. While AIGC has been trending, another term has also gained popularity: full generative AI. From a literal perspective, the relationship between generative AI and AIGC is easy to understand. The content generated by generative AI is AIGC. Therefore, ChatGPT, GitHub Copilot, Midjourney, and others all belong to generative AI. As you can see, the concepts of AIGC and generative AI are quite straightforward. However, since the term AIGC is more popular in China than generative AI, in many contexts, AIGC is also used to refer to generative AI. So, what is the relationship between generative AI and terms like AI, machine learning, supervised learning, unsupervised learning, reinforcement learning, deep learning, large language models, and more? Does it feel tangled and complicated? It's hard to sum it up in one sentence, but a single diagram can help you visually understand their relationships. AI, also known as artificial intelligence, is a discipline under computer science. It aims to enable computer systems to simulate human intelligence to solve problems and complete tasks. AI was established as an academic field as early as 1956 and has experienced multiple cycles of boom and bust over the decades. Machine learning is a subset of AI. Its core idea is to allow computers to learn and improve on their own through algorithms, without explicit programming by humans, to recognize patterns, make predictions, and decisions. For example, if we tell a computer through code that red in an image means rose and orange means sunflower, the program's judgment about flower types is achieved through direct and explicit human-written logic. This is not machine learning. The machine hasn't learned anything. But if we provide the computer with a large number of rose and sunflower images, allowing it to recognize patterns and summarize rules on its own, so it can predict and judge unseen images, that's machine learning. Machine learning has several branches, including supervised learning and reinforcement learning. In supervised learning, the machine learning algorithm receives labeled training data. Labels are the expected output values, so each training data point includes both input features and the expected output. The algorithm's goal is to learn the mapping between input and output, so that given new input features, it can accurately predict the corresponding output. Classic supervised learning tasks include classification, which divides data into different categories, and regression, which predicts numerical values. For example, training a model with a bunch of cat and dog photos along with their corresponding cat or dog labels, then having the model predict whether an unseen photo is a cat or a dog. This is classification. Training a model with housing data like area, number of bedrooms, balcony availability, etc., along with corresponding house prices as labels, then having the model predict the price of an unseen house based on its features. This is regression. Unlike supervised learning, unsupervised learning uses data without labels. The algorithm's task is to independently discover patterns or structures in the data. Classic unsupervised learning tasks include clustering, which groups data. For example, providing a collection of news articles and having the model automatically organize similar articles based on themes or content features. Reinforcement learning involves a model taking actions in an environment, receiving feedback on the results, and learning from the feedback to take the best actions in given situations to maximize rewards or minimize losses. It's like training a puppy. At first, the puppy will act randomly, but as it interacts with the trainer, the puppy discovers that certain actions earn treats, some earn nothing, and others might even result in punishment. By observing the connection between actions and rewards and punishments, The puppy's behavior gradually aligns with the trainer's expectations. Reinforcement learning can be applied to many tasks, such as teaching a model to play Go. The model receives feedback on rewards or losses resulting from different actions, optimizing its strategy over multiple games to learn how to take actions for a high score. Now, the question is, where does deep learning fit among these three? It doesn't belong to any of them. Deep learning is a method within machine learning. Its core lies in using artificial neural networks to mimic the way the human brain processes information, extracting and representing data features through a hierarchical approach. Neural networks consist of many basic computing and storage units called neurons. These neurons process data through layered connections, and deep learning models typically have many layers, hence the term deep. For example, to enable a computer to recognize a photo of a kitten, in deep learning, the data is first passed to an input layer, much like how human eyes see an image. Then, the data goes through multiple hidden layers, each performing complex mathematical operations to help the computer understand features in the image, such as the kitten's ears, eyes, etc. Finally, the computer outputs an answer indicating whether it's a photo of a kitten. Neural networks can be used in supervised learning, unsupervised learning, and reinforcement learning, so deep learning is not a subset of them. Generative AI is an application of deep learning. It uses neural networks to recognize patterns and structures in existing content, learning to generate new content in forms such as text, images, audio, and more. Large language models, also known as LLMs, are another application of deep learning, specifically designed for natural language processing tasks. The large in large language models indicates that the model has a massive number of parameters, potentially tens of billions to trillions, and requires vast text datasets during training. This enables them to better understand natural language and generate high-quality text. There are many examples of large language models, such as GPT and Llama internationally, and Ernie and ChatGPT-M domestically, which can perform text understanding and generation. Taking the GPT-3 model as an example, it generates text sequences step by step by calculating probabilities based on input prompts and previously generated words or tokens. However, not all generative AI models are large language models, and whether all large language models fall under generative AI is somewhat debatable. The first part is easy to understand. Diffusion models that generate images are not large language models, as they don't output text. At the same time, some argue that not all large language models are generative AI because certain models, due to their architectural characteristics, are not well suited for text generation. Google's BERT model is an example. It has a large number of parameters and training data, qualifying it as a large language model. In terms of application, BERT excels at understanding context, so Google uses it in search to improve ranking accuracy and information extraction. It's also used for tasks like sentiment analysis and text classification. However, BERT is not adept at text generation, especially coherent long-form text generation. Therefore, some argue that such models do not fall under the category of generative AI. These concepts collectively form the core elements of generative AI, and I hope this helps you gain a better understanding of the trending AIGC. In the next section, we'll delve deeper into large language models. See you in the next video.